So we're trying to find where this function has branch cuts, given that the square root function has branch cuts along the negative real axis. So the easiest thing to do first is to find the branch points. Now remember, the branch points are where the thing inside the square root is equal to 0. So to find the branch points, we set e to the z equal to -1. We can solve that by taking logs, so we end up with z equals log of -1, which we now know is equal to, okay, do it. We've done this before, but basically it's I pi plus 2 pi n for any integer n. Okay, so we get that set of, they're the branch points. So we know that the branch cuts will start at that set of points. So okay, I'll write them a slightly nicer way. So it's z equals 2n plus 1 I pi. To find the branch cut, we just have to remember that the branch cut is when the thing inside the square root is along theta equals pi, which basically means the thing inside the square root needs to be real and negative. So we need to think, when is this thing real and negative? So it helps if we then split the z into real and imaginary parts as usual. So z equals x plus iy, where x and y are real, and we're basically asking when is, so okay, well, the branch cut is where e to the x times e to the iy plus 1 is real and negative. So in order for it to be real, well, obviously e to the x is always real. E to the iy is normally not real, except if y is a multiple of pi. Okay, so let's think about it. If y is, for example, 0, then there's no way for this. If y is 0 or 2 pi or 4 pi, if y is an even multiple of pi, then this will just be 1, and there's no way for this to be negative. So the only way that this can be real and negative is if y is an odd multiple of pi. Now this is looking hopeful because we seem to have odd multiples of pi appearing here. So we've sorted out the y value. When this happens, obviously, if y is equal to this, then we have e to the I pi, or e to the I 3 pi, e to the I pi, or e to the 3i pi, and so on. These are all equal to -1. So now we have that we need that 1 minus e to the x. So this is turning this into we've got a minus sign here, needs to be negative, so it needs to be less than 0. Which means that e to the x needs to be greater than 1, which means that when x is 0, you have 1. So basically that means when x is greater than 0. So what have we found? We've now found conditions for the branch cuts. So the branch cuts are when y is equal to this and when x is greater than 0. Oh, okay. Strictly, I said real and negative. The branch cuts, okay, well, actually also include 0 as well. Okay, don't worry too much about that. So now we can actually sketch the branch cuts. So may as well. So we're talking about the branch cuts of this function. So they're basically when y is pi or minus pi or minus 3 pi or plus 3 pi. Okay, so the branch cuts go to infinity, but they basically look like this.